Starship 36 or Ship 36 just exploded during static fire test. Everything just got wiped out at Massey's test site. Yes, you heard it right. Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started. Just now, a dramatic event unfolded at SpaceX's Starbase facility in Boca Chica, Texas, when Ship 36, a Starship upper stage prototype, exploded during a static fire test. According to the latest updates, the incident occurred during a critical pre-flight test involving the firing of its 6 Raptor engines, a routine step to verify the spacecraft's readiness for an upcoming orbital test flight. The explosion marked a significant setback for SpaceX, a company renowned for its ambitious goal of developing a fully reusable rocket system to enable human exploration of the Moon and Mars. This event, while not entirely unexpected, given SpaceX's iterative and risk-tolerant approach to rocket development, has sparked widespread discussion about its causes, implications for the Starship program, and the company's path forward. The static fire test, during which Ship 36 met its fiery end, is a standard procedure in SpaceX's testing regimen. During these tests, the spacecraft's engines are ignited while the vehicle remains anchored to the ground, allowing engineers to collect data on engine performance, propellant systems, and structural integrity. Ship 36, paired with the Booster 16, was slated to fly on Starship's 10th test flight, a mission intended to build on the lessons learned from previous flights, particularly the troubled Flight 9 on May 27, 2025. That flight saw Ship 35 reach its planned suborbital trajectory, but failed to achieve key objectives, such as deploying mock Starlink satellites, due to a propellant leak that caused the spacecraft to spin uncontrollably and break apart over the Indian Ocean. The June explosion of Ship 36, occurring just weeks after Flight 9, underscores the persistent technical hurdles SpaceX faces as it works to perfect the Starship system. While SpaceX has not yet released an official statement detailing the cause of Ship 36's explosion, insights from previous Starship failures provide a framework for understanding potential reasons. The Starship program has a history of dramatic mishaps, with Flights 7 and 8 in January and March 2025 ending in explosions due to propellant leaks and engine failures. For Flight 7, SpaceX identified stronger than expected rhythmic oscillations that caused propellant leaks in the upper stage's attic section, leading to fires that shut down all but one of the Raptor engines. Flight 8, meanwhile, suffered a flash in one of the center Raptor engines, resulting in inadvertent propellant mixing and ignition, which triggered the loss of multiple engines and the spacecraft's subsequent disintegration. Given these precedents, it's plausible that Ship 36's explosion during its static fire test stemmed from similar issues, such as a hardware failure in the Raptor engines, propellant feedline leaks, or structural stresses exacerbated by the intense vibrations of the test. Another potential factor could be related to the modifications SpaceX has been making to its Block 2 Starship design. Ship 36 was equipped with a new heat shield design, where the underlying felt was cut into hexagonal shapes and folded between tiles to act as a gap filler, aimed at improving re-entry performance. Additionally, SpaceX has been refining the Raptor engines and propellant systems based on data from previous failures. If these upgrades were not fully vetted or introduced unforeseen interactions, they could have contributed to the explosion. For instance, a post on X suggested that the static fire test may have revealed a non-nominal issue, potentially indicating an anomaly in the engine or propellant systems that led to catastrophic failure. Without official confirmation, speculation centers on these recurring themes of propellant management and engine reliability, which have plagued the Starship program in 2025. The explosion of Ship 36 comes at a critical juncture for SpaceX, as the company is under pressure to meet ambitious milestones. Starship is central to NASA's Artemis program, which aims to return astronauts to the Moon by 2027, with SpaceX contracted to develop Starship as a lunar lander. Additionally, Elon Musk's vision of colonizing Mars hinges on Starship's ability to become a fully reusable, rapidly deployable rocket system capable of carrying large payloads and crews. The setbacks of 2025, including the failures of Flight 7, 8, and now the loss of Ship 36, have raised concerns about the program's timeline. Each mishap requires SpaceX to conduct thorough investigations, often under the oversight of the Federal Aviation Administration, FAA, which regulates commercial rocket launches. The FAA's involvement ensures that safety and environmental concerns are addressed, but it can delay subsequent launches as corrective actions are implemented. Despite these challenges, SpaceX's engineering culture is built on a fail fast, fix fast philosophy, where test failures are viewed as opportunities to gather data and refine designs. Following the Flight 9 mishap, SpaceX made significant modifications to the Starship upper stage, including changes to propellant feed lines, additional vents, and a nitrogen purge system to mitigate fire risks in the attic section. These fixes allowed Flight 9 to progress further than its predecessors, reaching the scheduled engine cutoff and avoiding significant heat shield tile loss during ascent. However, the persistent issue of propellant leaks during the coast and re-entry phases suggests that SpaceX is still grappling with complex engineering challenges. The explosion of Ship 36 during a ground test indicates that these issues may extend beyond in-flight scenarios, potentially pointing to flaws in the ground testing process or hardware integration. Looking ahead, the loss of Ship 36 is likely to impact preparations for Starship's next test flight, Flight 10. Originally, Ship 36 and Booster 16 were expected to launch as early as July 2025, based on Musk's comments after Flight 9 about accelerating launch cadence to one flight every 3 to 4 weeks. However, the explosion will almost certainly delay this timeline. SpaceX has a fleet of vehicles in various stages of assembly and testing, including Ship 37, which is slated for Flight 11, and Booster 17, the final Super Heavy prototype of its generation. Ship 37 has already undergone cryogenic proof testing and is being prepared for static fire tests, while Booster 16 has completed cryogenic and static fire tests at the orbital launch pad. SpaceX may pivot to using Ship 37 or another vehicle for the Flight 10, but this would require additional testing and integration, potentially pushing the launch to late summer or early fall 2025. The FAA's response to the Ship 36 explosion will also play a significant role in determining the timing of the next flight. After the Flight 8 explosion in March, the FAA grounded Starship pending an investigation, which concluded in May with approval for Flight 9. The agency's review process involves assessing the mishap's root cause, ensuring SpaceX implements corrective actions, and verifying compliance with safety and environmental regulations. Given that the Ship 36 explosion occurred during a ground test rather than a launch, the regulatory impact may be less severe, but the FAA will likely require a detailed report before approving further tests or launches. This process could take weeks or months, depending on the complexity of the failure and the extent of the damage to the Starbase facility. The explosion's impact on SpaceX's launch cadence is a critical concern. Musk's goal of conducting up to 25 Starship test flights in 2025 is already unattainable, with only 3 flights completed by mid-June. The loss of Ship 36 further jeopardizes this target, as SpaceX must allocate resources to investigate the failure, repair any damage to the test stand, and prepare a new vehicle for flight. The company's iterative approach relies on frequent testing to identify and resolve issues, but repeated setbacks could erode confidence among stakeholders, including NASA and commercial partners. For instance, the Artemis 3 mission, which depends on Starship's success, requires at least one uncrewed lunar landing and return to orbit before 2027. Each failure pushes this milestone further out, potentially delaying NASA's lunar ambitions. SpaceX's response to the Ship 36 explosion will likely follow its established playbook: analyze telemetry data, identify the root cause, and implement fixes for future vehicles. The company has a robust production pipeline, with multiple Starships and Super Heavy boosters in various stages of assembly at Starbase. Ship 37, for example, is nearly ready for testing, and SpaceX has been working on Block 3 Starship designs, which promise further improvements in reliability and reusability. These next-generation vehicles may incorporate lessons learned from Ship 36's failure, such as enhanced engine diagnostics or reinforced propellant systems. Additionally, SpaceX's success in catching Super Heavy boosters with the Mechazilla-launched Tower arms in Flights 5, 7, and 8 demonstrates progress in booster reusability, a key component of the Starship system's economic viability. As SpaceX prepares for Flight 10, the focus will be on integrating lessons from Ship 36's explosion into the next vehicle. Ship 37, which has completed cryogenic testing and is undergoing final assembly, is a likely candidate to replace Ship 36. The objectives for Flight 10 will depend on the outcome of Flight 9's data analysis and the findings from the Ship 36 investigation. Key goals include successfully deploying mock Starlink satellites, relighting a Raptor engine in space, and achieving a controlled re-entry and splashdown in the Indian Ocean. These milestones are critical for validating Starship's payload delivery and reusability capabilities, which are essential for its role in deploying large satellite constellations and supporting crewed missions. Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.